pleasant morning to all my dear students. Hope you are doing great. So I am here with a new chapter, Atoms and Molecules today. So hope you have collected some information about the basic definitions of few terms that I have given you already, that is atoms, molecules, ions, etc. And I have asked you to collect some information about the valencies as well as the names of the first 20 elements in order. Please do write that and stick that paper in your classwork. That's really very important and it's going to help you a lot in your future, children, not only for your 9th but also for your 10th. Please keep it carefully and please do learn. So let's start quickly our next chapter, that is atoms and molecules. So as you know, children, the science and technology, the world has witnessed so many inventions and discoveries, actually some which have already fetched great rewards and awards to the scientists also. Like imagine discovering something which cannot be seen, which cannot be which is unknown, which is unseen to the humans. So such a discovery, one of such discoveries is nothing but about atoms, children. There was a lot of speculation among the scientists regarding what matter is made of and how different things are different from one another. What is the building block that is actually composing or constituting the matter that is around us. So such an idea started early, around 500 BC. At around 500 BC, scientists, great scholars from India actually, like the Maharishi Kanad, already started thinking about the constituents of the matter, the composition of the matter. So he said that if you go on, it is nothing but he postulated the divisibility theory, or what we call as he postulated that when you go on dividing a particular substance, like for example you take a piece of wood or a chalk or whatever, you divide it into two, you make it into two, and the other two pieces you make them again into half. You go on dividing any substance and you get smaller and smaller and smaller substances, smaller and smaller objects, or what you call pieces of that substance. So when you continue, when you go on dividing, ultimately you will reach a stage where you will get one thing, one simplest thing which cannot be divided further. So that thing, he named that as Parmanu. What is it? It is Parmanu. So he said this is the thing that will be resulted if you go on dividing a particular substance until Parmanu is indivisible. Beyond that you cannot divide any substance. So he named that as Parmanu. So this is the main concept. Already it's seeded in Maharishi Kanad's mind. So then the Pakuda Katyayama, he is another scholar from India. Again he said that these Parmanus only, they mix with each other, they combine with each other and form different molecules, or the matter that is present. That's the reason different matter, the composition of different matter depends upon the combination of these Parmanu. See, already they got the whole idea behind the composition of matter, isn't it, children? Now we know that atoms combine together to form elements, and elements and different atoms combine to form compounds, and the whole universe or the matter is made up of these different elements and compounds only. So this idea seeded long back in the minds of the scholars at around 500 BC itself, and they named it as Parmanu. So we can relate this Parmanu as to that of atoms now, children. So did you understand? So, but it was just theoretical. It was just a thought that came into the minds of these scholars. At around the same time, Democritus and Leucippus, both of them had a similar idea. He also postulated the divisibility rule, or what you call divisibility theory. When you go on dividing a particular substance, you get ultimately the simplest substance, which cannot be divided further, and he named it as atom, children. Atom in Greek means indivisible. It cannot be divided further. So Democritus and Leucippus together had a similar idea what Maharishi Kanadan Pakuda Katyayama had in around 500 BC in India, children. So then it was like, it was just a thought and there was no experimental proof to validate their thought. So nothing was there to prove their hypothesis or theory. We didn't know, people didn't know whether what they are saying is true or not also. So there was no work happening till 18th century, children. Till 18th century, there was absolutely nothing going on further. The research or whatever, it just halted. It came to a halt. That nothing happened till 18th century. But in the 18th century, again, as Greek scientist Antoine L. Lavoisier, he actually postulated three laws actually. So he postulated very important laws that really validated all these things which were put forward by the scholars before him. So we will be learning about the laws later. First of all, let us have a very clear idea about what these atoms are, what this Parmanu is, how they combine with each other and all. So let's go into the basics first and learn the new things in this chapter later. So I already gave you, most of you might have collected information, definitions of all these things. Let's revise it again. So did you get an idea, children, how it all started? So what were the contributions of the scientists? Very important to know. Antoine Lavoisier, he postulated laws which validated the theory of atoms and all. Okay, this we will be learning later. Let us see the definition of atoms now, children. So as you know that it is the smallest basic unit of matter. It is the smallest basic unit of matter, like a building block of matter. Imagine a house built. So it is built with so many materials, isn't it? We need sand, we need cement, we need iron, we need bricks, isn't it? Just consider a construction of a wall. We need all these things. A concrete wall, for example. We need all these things. So what is the basic thing that we require to? So all these things are nothing but, iron is one kind of atom. Imagine, just compare. And the bricks, another kind of atom, the sand, another kind of atom. So what is happening? All the different atoms are combining to form a wall. Nothing but the wall can be considered here, can be compared to that of a molecule here, a compound here, or a mixture, anything. So what is the basic thing that we started with? That is nothing but atom. It is the smallest basic unit of matter which cannot be divided further. One more very characteristic feature, or what you call very important to know about atoms, is that they are unstable, children. They attain stability once they are in combination with other atoms only. A single, alone, atoms cannot be stable alone. They have to combine with another. Either later you will learn that either by sharing of electrons, or by giving away electrons or taking electrons, whatever, they will be actually combining with others. Then only they get that stable configuration. So alone they are unstable and they are indivisible. Smallest basic unit of matter, atoms combine to form molecules. Now we know that different atoms actually combine to form molecules. Now molecules again are of two types. In my last video I think I told you that molecules are of two types, elements and compounds. If same atoms combine, then they are called as elements, and if different atoms combine, they are called as compounds, right? So molecules are of two types, elements and compounds. It's made up of two or more atoms. So we can't say that only two atoms combine or only three atoms combine. They combine in variable number, and they form molecules. So can you give some examples of atoms and molecules and elements? So please do write down few examples at least in your rough book of some atoms, some molecules and some elements, compounds and elements. You should have, because I think in the periodic assessment most of you could not actually understand which one is a mixture, which one is a compound and which one is an element. So there you need to have a very good idea about what are elements and what are compounds and what are atoms. Actually, atoms, you can just consider them as, you know, same atoms, they combine to form elements only. So elements and compounds and mixtures, you need to have a very good idea, children. Okay. Coming to the valency, this is very interesting and very important concept that you have to know now. Then it becomes easy for you to understand different things in the 10th. So this is the time when you have to have a clear idea about valency. As you know that in our 8th class, while discussing about metals and non-metals, I explained you about the atomic structure in brief, right? Do you remember? So an atom consists of a nucleus, and around the nucleus you have orbits, and on the orbits, actually along the orbits, that path, actually electrons will be revolving around the nucleus. Now, when you see that the outermost orbit, that number of orbits depends on the size of the atom. When the size of the atom is bigger, they have more number of orbits in them. So you can see that the outermost orbit will have some electrons, and that decides the combining capacity of an atom. So what is valency? The combining capacity. With how many atoms will a particular atom combine? Can a particular atom combine to attain? What is the ultimate need for combination, children? As I told you that the atoms are unstable if they are alone. So when they combine with other atoms only, they get stability. So how can you say that a particular atom will combine with how many different atoms? So that is given by nothing but valency. So how is on what is this valency in turn depending on? It is depending upon the number of electrons that are present in the outermost shell of the atom. So shell is nothing but an orbit, right? So if there is one electron present in the outermost shell, then you can see that that particular atom can give away that electron, and combine with another atom. It can give away its electron to the one which is needing that electron. Okay, two atoms can combine either by sharing of electrons or by transfer of electron. Whether if an atom has an extra electron, it can give away that extra electron to another atom which is deficit of these electrons. So in that way there will be a bond formed between two atoms, and they form elements or compounds. I told you, combination of atoms, right? Atoms combine to form molecules. I said, how is this combination happening? For now, just understand that this combination happens either by sharing of electrons or transfer of electrons. So with how many atoms will this atom combine will be determined by valency, combining capacity of an atom. It is the maximum number of electrons. See, very important, please do write in your homework. It is the maximum number of electrons an atom loses or gains or shares to become more stable. So we'll be learning about all these things later in your 10. Don't worry about it. For now, you understand that combination can happen by either gaining electrons or losing electrons or sharing electrons. So that gives you the combining capacity of an element, that is valency. Best example, for example, if you take sodium, it has one electron in its outermost shell. Okay, it has total number of 11 electrons, and one electron is present in the outermost shell. Now that electron, it can give away to another atom so that it combines with another one atom. So its valency is 1. Okay. Usually metals have positive valencies. That means they give away electrons, and non-metals have negative valencies. They accept electrons. When an atom gives away an electron, it gets positive charge. Already I discussed this all in your 8th class when I discussed about the cations and the anions, isn't it? How an electron gets a charge, how an atom gets a charge. If it loses, it gets positive charge. If it gains, a negative ion, negative charge is gained. So then you get a negative charge. So that is about the valency, children. Okay. In my next video, I'll be talking about the atomicity. So atomicity is nothing but how many atoms are present. Okay, how many atoms are present in a molecule. For example, if in a molecule I said 2 or more atoms combine to form molecules, if it is only made up of 2 atoms, then it is called as diatomic. If it is only if it is 3 atoms, then it is called as triatomic. If it is having more than 3, then we call it as tetra, penta or polyatomic molecules. So can you give some examples for diatomic, for monoatomic? Mono means it contains only single atom which can be stable. Sometimes it happens that also happens. There are some examples where a single atom can be stable. So please give some examples for monoatomic atoms, diatomic molecules, triatomic molecules and poly or tetra or polyatomic molecules. Let me see whether you can get examples for all these things or not. So that's all for today. In my next video, I'll be teaching you some more very important concepts of these atoms and molecules. Please do follow these videos very carefully, because this is the basic, the basis, you need to have good knowledge about all these things. Then only it will be easier for you in your 10th.